Okay, in this video, I'm going to be talking about the reduction of acyl chlorides. So let's look at this simple acyl chloride. Let me make this bigger. And we are going to react that with lithium aluminum hydride in THF, which is just this right here. Tetrahydrofuran, I believe. Anyways, that's the first step, and then we'll have to do some protonation step, a little acid-base chemistry, just acid really, because HCl and H2O. This is just a protonation step, and we'll get something that looks like this, with two hydrogens being attached right there. Now you may be asking yourselves, how do we get to this point? Well, I'm going to show you that mechanistically. So let me erase this stuff. I'll keep this THF right there. So a shortcut to show this is we're going to be using hydrides in our reactions. So stuff like H-. This makes things look a lot more simple, and you can see how this works, I guess, easier. Obviously my grammar is horrible when I'm talking, but anyways, let's keep moving on with this problem. So this H- is basically just going to attack this carbonyl carbon and push these electrons onto this electronegative oxygen, and we're going to get something that looks like this with an O- and an H being attached right here. And keep in mind, we have this chlorine still here, and chlorines are a really good leaving group. So what we're going to do is we're going to shift these electrons back onto this bond right here to make a carbonyl group, a double carbon double bond oxygen. And then we're going to have to kick off a chlorine. And then we're going to get something that looks like this with double bond to our oxygen and our hydrogen. I'm just going to put this guy right here so things look a lot neater. Anyways, so we're not done yet. We have plenty of sources of hydride. Now we could stop right here if we used a different reagent, and that's in a different video I did, but I'll tell you what that reagent is. That reagent is lithium aluminum with a tert butoxide group, T-butyl, with an H. So that would be the reagent needed to stop right here to an aldehyde, but we're not doing that in this video. We are reducing it to the very end. So let's use another H- to attack this carbonyl carbon, shift these electrons back onto this oxygen, and we'll get something that looks like this, an O-, an H, which is, let me color code this so we know. So H, let's make this blue. Oh, that's not blue, that's a horrible color. There we go. So this H- is going to attack, and we're going to put it right here. Let's go back to red. And then we're going to have this O-, and then our electrons can't reform this pi bond. We can't do that, because if we did, we would get so many bonds. We would have 1, 2, 3, 4, 5 bonds. No, that does not happen. So what we're actually going to do is protonate. This is going to be our last step with this, the second step. Let me reform this. O-, we're going to use this HCl. So this is our second step. Hold on a second. Let me see if I can find some room. Write it up here. So our second step is to use HCl, H2O. H2O. So we can just use a proton. So let's just do a proton. It's going to attach right there to give us a final product of OH with our two H's. keep in mind we don't have free floating protons in solution. They don't exist. So if your professor is really stingy about giving out points and docking points, you can use hydronium. And then just, let me erase this. And then just take a proton of that and then shift those electrons to give your final primary alcohol. So this is your final product. I hope this video made sense. If you have any questions, please feel free to leave a comment down below and subscribe for future videos. Thank you for watching.